Crawling the web with Elixir. Let's see if this works this time. Or how I slept a little easier on the beam. This is a true story about probably about the last, up until 2018, about a 7-year period where I was crawling the web at an extremely high scale and some of the pain that I went through. So, a little bit about me. My name is Adam Mokan. I'm the Director of Engineering at HiringSolved, which is a small startup that was originally based out of Chandler, Arizona, where I reside, but we are mostly a distributed team working remotely. And all of the things I'm going to be describing here are actually prior to this change. I joined HiringSolved about a year ago and got out of the crawling game because I just, it's one of those things that ages you a little bit. I'm actually 19, so as you can see what crawling has done to me. You got the GitHub handle there. If you can get there, you can track me down. I don't think there's another Adam Mokan out in the world, but if you do find another one, let me know. And just another note, too, about the company I work for, HiringSolved. Generally, what we do, in the most basic sense, we work with like Fortune 1000 companies to take their data when people apply for jobs and help their recruiters find diamonds in the rough, find those long-tail candidates, I guess you could say. So basically, we try to help people get jobs, and that's the basics. And I apologize about that flashing. So, what should you expect from this talk? One of the first things, we're just going to talk about the basic anatomy of a crawl, and you'll understand why I put those quotes around it. General implementation overview, some of my technical challenges I faced over the years, and hopefully you take some ideas out of this. I really, for your sake, I hope people in this room aren't crawling too much or scraping. If you are, I'm sorry. You might learn a couple things, who knows? But if you're not, I think there's a lot of parallels in some of the trouble that I faced in some of this work that might benefit, a number of you out there. To be clear, though, I will not be covering things like avoiding bot detection methods. I'm not going to be talking about proxies and, things like that. And in general, anything that's sketchy. There are some legal issues depending on where you live. I'm not going to go down that road. If you want to talk shop after, you reach out. But I think I've kind of nailed where I'm going here, though. My talk is titled Crawling the Web with Elixir. And you're going, well, wait a minute, why are you worrying about bot detection, right? Well, it's a gray area between crawling and scraping. Has anybody in this room actually done crawling, scraping? A lot of you. How many of you are doing it like as a full-time job right now? Anybody? Okay. So, let's be honest. Not a lot of people talk about it. Not a lot of people want to discuss it. It seems like everybody's doing it. There's a lot of parallels and some other things here, but it's, rather than get into nomenclature, honestly, when I read scraping, it looks like scrapping. Maybe it's, I'm intellectually weak, I don't know. But so I think, I'm just going to use the word crawling. Let's just all agree that crawling is going to be the term that we're going to use the rest of the talk. And it does involve actual crawling, your old school web spider type stuff. Some of that work I have done. And, but at the end of the day, it's gathering data, let's be honest. And, kind of in my little blurb about this talk, I have been doing this for a long time. I started, scraping terminal screens in the late 90s. Scraping UIs and things like that and bringing them to a more modern interface in real time. So I have a long background there. That's definitely one of those things I've been doing. And, again, let's get into some use cases really quick. These are the common ones. I'm sure some of you that are crawling or scraping, again, we're going to say crawling, you may be using data for these purposes. I don't really care what you're using the data for, but again, it's being used. And for anybody not really familiar or that isn't working in the space, nearly every aspect of your daily life is relying on scraped, crawled, whatever you want to call it, data, right? Whether it's data that is being given to another person by a provider or if it's being grabbed in the open internet, the phone in your pocket. I'm not even getting near the social media stuff. I mean, to put it out there, I don't crawl anything behind a paywall or a login. It's just not something I'm willing to do. But everything from the food you buy at your supermarket, those prices are going to be dictated by somebody crawling data someplace. And that's happening on a daily basis. Been happening for years. So just want to make sure we're all on the same page on some of these use cases, and I know there's a lot more. What makes it challenging? These are all common sense things that it's not unique to this work, but the internet, obviously that's something that can throw you a curveball. But scaling, in my experience, a lot of work that I've done in the past where you have a consistent data flow, it's easy to kind of start thinking about where can I scale out horizontally. A lot of times it can be linear up to a certain point. With my work in crawling, I've never been that fortunate. I can go price something out and go, yeah, I think for this much money we can hit this number. I've been burned by that so many times because things just get bigger and they do not scale in a linear fashion traditionally, at least in my experience. HTML, if you are crawling, that is awful. If you're crawling web pages, and depending on layouts, depending on what you're crawling, some of you may have experienced things like you run the same crawl again, and the same exact URL, and the layout has changed on you. That can be a method where somebody's trying to stop you from doing said crawl. But it's an extremely difficult challenge, again, at scale. Modern web development has definitely influenced a lot of the work in this that I'm going to discuss. When we started seeing an advent of single-page applications, lots of client-side rendering, things like infinite scroll, what that ended up doing was made it so you couldn't really have a lot of success with something like just a simple HTTP library. It made it very difficult to pull that off. You just had to start working into headless browsers and things like that. So let's look at the most basic general idea here when you're trying to grab some data off the web. So chances are you're starting with some data source. That could be in a database, queue, work queue, whatever you're working with. And what we're going to do for the next few minutes here is we're going to talk about this as a crawl job, quote unquote, at least in my world. So we pull a crawl job. There might be some initialization there, validation. Chances are we might be, if we're mocking a user agent or things like that, you might do this at that first step after you pull the job. I'm really sorry about this flicker.
Are you using Jose's computer?
I am not, no. Should I pause and fix that? Okay, fair enough. So I shouldn't have used white backgrounds. Okay, sorry. So at that point, we have our job. We would move on to an HTTP request. Again, let's ignore what I just said about single-page applications and headless browsers. So this would be more of a traditional situation where, regardless of language you're using, if it's Python, URL lib3 or something could be your HTTP client, you are taking that job, you're going to go make a request, right? At that point, we went and fetched, try to make a request. And I'm not seeing my updates on the screen, that's cool. And I must have jumped too fast there. Okay. So you guys get the general idea, though. This is basic stuff. We go out, make a request, we get the response, we parse it. We're probably going to store those results someplace. We'll persist them. And then rinse and repeat, right? Simple circle of life, I guess you could say, of crawling. So then if we want to kind of step up a little bit and go, how do we start working with this in reality? What we just looked at, that so-called circle of life there, you could imagine inside a worker process. We have a job queue, we look at that worker process, and okay, we have one process right now, we can go do one crawl at a time, right? So then how do we scale out? We can spin up more processes. This could be as rudimentary as Ruby processes running that are doing the crawls, spinning them up with cron tab, and you want to go a little bit horizontal there. You can run this on multiple machines, depending on what your job queue mechanism is, and go get your data, return the results, parse, rinse and repeat again. So, this doesn't sound all that hard, right? It's not rocket science. And then this was my normal day for 6 years. So, probably a flashing screen. Maybe these aren't huge numbers, but for me, they were painful. 7 million on-demand crawls a day, that was kind of my low end. That was a low day for me. I didn't know when I woke up when those 7 million were going to come. It could have been before I woke up that day. It could have been at 11 p.m. I was managing over 100 physical servers to orchestrate this infrastructure. And I had a goal. I had to keep the error rate down below 1%. If you couldn't deliver data, customers simply don't pay, right? I mean, at the end of the day. And then we also had delivery time, SLAs, everything from 10 minutes turnaround to max of 24 hours, depending on the amount of money that they were willing to pay for that data. So, and when I say a delivery time, that's kind of per job. So if you think about an individual thing you're going to fetch, I had about 10 minutes to return that on a high priority SLA. Now, the harsh reality is I could have had somebody come in and pay big bucks and want to just fill the on-demand queues with a ton of priority work. Well, somebody else comes along and wants one too. I still got to deliver that guy at the back of the priority queue. I got to deliver him in 10 minutes. So, after a couple of years of this, it's not really hard work, but I can identify with this feeling because you just feel tired. It wears you down because you're getting woken up at night. With those SLAs I had, sleeping became a problem. So by the summer of 2016, I was like, I can't do this anymore. I kind of stepped back and I'm looking at the big picture there. I actually had some background experience with Erlang going back into 2010. And I was like, a lot of these moving parts, I wasn't going to solve them with any programming language or environment, but I could at least make my life a little bit better. And that's what I sought out to do. So after about 5 to 6 weeks, I had posted something on the Elixir forum. There was a topic. It was like, hey, what's everybody working on? And I was pretty happy because I had just launched this thing, and this is kind of a little excerpt. If you look my name up in the forums, you'll see some pretty detailed threads about this. And I launched the system internally, obviously, and it was actually doing really well, and it was used in particular for a couple specific clients that had some really heavy use cases that I just couldn't fight with in other languages. So some of the libraries and tools I used for this, I should have really reordered that because GenStage is really the star of the show in a lot of areas. Phoenix PubSub, I used Tracker extensively. Floki I was using for parsing. ElixirConf for some of the port handling. This is the elephant in the room here, Nightmare.js. And you might look at that and go, what's going on? I thought this was an Elixir talk. I'm not a fan of Node. I'm not upset with anybody that loves Node. I understand the appeal. Never been one of my things I've pursued, but I will give that community credit. when it comes to the headless browser testing tools and things like that. It was a great fit, kind of piggyback at the end of the Elixir, right? So I did a lot of that heavy lifting in Elixir. I would kick off using Elixir, a port in Erlang, spawn off a nightmare process, grab the results back from the std out, and I had the confidence that those processes I was spinning up, I could monitor those, supervise those. I knew when they crashed, was able to kind of orchestrate that really well. So this is the really high level of that architecture. You might see the 1.5 up there. That's because 1.0 is terrible. I don't even want to talk about that. There's some mentions of it in the Elixir forums, but it is really not worth going over. But my job source was Redis. We use Redis list extensively, and despite contrary belief, you can't do some reliable queue tricks with Redis using a number of commands. But Redis was already in place for us. We had a lot of other crawlers running in different languages, and Redis was there, so I didn't want to reinvent the wheel. And basically what I came up with was, it's important for me to state that what I'm going to talk to you about, it's using distributed Erlang, but it's not a heavily resilient distributed system where a node could go down and the work's going to get passed off magically. I had a concept of a master node, and that's why I want to mention that right now. So on that master node, it had some pretty key responsibilities. Get the job. Jobs are being fed in from GenStage. The master node would be responsible for dispatching that job once it reached a certain state to a crawler node. And to be clear, I had, I think, 24 crawler nodes, I believe, at about the time I had launched this. So you can imagine I had a master node kind of orchestrating the work, and 24 crawler nodes. This was all on-premise in my own data center. Now, the other thing that you might notice there is the RPC connections between the master node and the crawler node. And we'll get into that later, but that was not ideal, and I will explain why. But another mention on the nodes, I was using things like node monitor to get callbacks and indicator that any nodes dropped out of the mesh. So I did have some resiliency in that form. So, again, those node connections, one thing, all the crawl nodes, they knew the name of the master node. I built the system. I was in my own data center. I didn't need to do a bunch of discovery. I used Phoenix Tracker. Again, this was a standard OTP system. No Phoenix was in the system, really, but Phoenix PubSub library comes with Phoenix Tracker, and it does a great job for managing, using like a CRDT of some metadata. So when a node would connect to the master, I would maintain that. The nodes would then kind of indicate what their current state was, statuses, and that way I had a real-time web UI that could easily read from that shared data structure and easily show what's on the screen. Now let's look at the internals of that master node at a high level. So I had a job producer. Again, for anybody that's worked with GenStage, this would be pretty simple stuff. The job producer was connecting to that Redis, my job source. It's pulling in work. I'd set my boundaries. I was using a consumer supervisor. They were called dynamic supervisor, I believe, at the time when I originally wrote it. Not to be confused with the current Elixir standard library dynamic supervisor. But for anybody that hasn't worked with GenStage in this fashion, you can basically tell it, I want to have a bounds, a max demand, how many processes I want to spin up under this child supervision tree. And it's going to use back pressure and all of the niceties of GenStage to bring work in, but not, it's not a push. It's pulling work in on demand. Processes will exit, and new work will be pulled into the supervision tree. So again, the data comes in from Redis. And then what you'll see is when it would start spinning up these processes. And this is really unfortunate. And as soon as they would pop, the process would come in, they would instantly go publish their information, basically initialize. Right after initialization, these gen servers, they would go in and they'd tell the Phoenix tracker, hey, I'm alive, I'm a process, I'm here to do some work. And they would already have a job assigned to them at that point. The next stage here this white background's killing me. I don't know, maybe it already had flashed and I missed it, but basically the next stage there would be the state of those processes. Once they've got the job, they've checked into that Phoenix, the tracker, they'd get to a state where they're ready to make a crawl. And at that point, they would send an RPC request to one of my crawl nodes. And again, let me step back. I'd mentioned that I was tracking my node list. I could have just used node list, but I was tracking some metadata at all times. The system would basically look and figure out, oh, which crawl node has capacity right now. And it would choose, based on that, which node to make the RPC call to from the job process. And basically, the job would tell the node, when it dispatched the job, the individual process running on my master node would do a self call. It knew its PID, and it would send that along with basically a struct of data to a crawl worker. So if we think about that job process in a little detail there, I mean, it's a gen server. It was pretty basic. It joined the tracker process, as I had mentioned. I'd say 90% of the logic in there was self-progression of state. A lot of send to self calls, process send afters, things like that. And the first version of this was pretty gross. 1,500 lines of code in that gen server. And there was a lot of high-level statuses. There were atoms, so again, pattern matching was nice and easy in those calls. I just threw a couple of basics in there. Obviously a new process. You might have a status where it's validating the job before you continue, because if you got work that came in that is not worth crawling for some reason, or maybe you had just crawled it, you might not continue at that point. So basically think of it as it was a state machine at the end of the day. One of the ways that I handle a case where, imagine if, because of these RPC calls, you send a work out to a crawler, that crawler could go offline. So these processes also kept track. They knew when they had sent the crawl to be scheduled. And within a certain time period, again, using a process send after inside that gen server, they could come back in 5 minutes and go, I never got data back, so I'm just going to send it out again. And so, just by that nature, it was semi-resilient. So one of the, this is the crawl architecture. Now, the thing I want to mention about the crawl architecture, this is the crawler node. It had another gen stage producer / queue inside of it on each node. And then there was a crawl supervisor. Again, I'd mentioned I was doing RPC to here, and I was depending on a CRDT to tell me that crawl node 5 had 20 jobs currently running on it, and crawl node 6 had 200 jobs running on it. Well, anybody that's worked with a CRDT knows that that's not exactly the most real-time information, depending on your topology. So this became problematic because things could get easily unbalanced in the cluster overall. Again, this is the example here. One of the first things that would happen when a process did go into the crawl queue is it would send an RPC request back to my master node and just say, hey, I'm a process that you sent over and I'm ready, I'm going to start working now. I'm almost ready to crawl. So I'd get real-time updates again in my user interface saying these jobs are out on which nodes, what's going to happen. And then we would kick off that nightmare.js process per process. So I did have some constraints I had to adhere to because on a piece of bare metal hardware, you can only do so many concurrent headless browser crawls at the same time. So again, the whole idea here was to have more machines running in the cluster. And for this data in particular, in this project, this is what my average month looked like right after launch. About the time I'd posted it on the Elixir forums, 16.5 million crawl jobs is what I was doing per month. And in that month, I had 500 errors. And what I'm defining as an error is just a straight up, everything blew up. And that means a single job. That doesn't mean I had 500 and the beam never crashed and anything like that. But I had 500 jobs I just didn't finish for whatever reason, which was totally acceptable. I was running 24 nodes. That's crawl nodes. So I had 25 nodes in the cluster. And at that time, I was running about, I don't remember which hardware I was on specifically. It was on-premise, though. It was bare metal. 17 Nightmare.js procs per bare metal machine. And so if you think back to the gen stage consumer supervisor on each crawl node, I basically had a max demand of 17 there. Keep it simple. And you can see our error rate is actually pretty awesome, given the nature of it. And to be clear, this system ran for approximately 2 years straight. Yes?
Is one crawl job generally crawling one URL or one site?
It depended. So what was just asked is if one crawl job represented one URL or one site. We'll touch on that a little bit more in detail, but I will say that in this particular case, it was multiple pages deep of certain sites. And because of that, and for anybody that has done multiple page crawling, a lot of times you will not want to be too aggressive and jump to the next page right away. You'll have pauses, right? And if you think about the nature of something like a headless browser, I don't want to do those pauses and sleeps in that browser because I am wasting time that I could be using that bare metal for something else. So I would know which page I was crawling, send the data back. I was keeping those browsers hot, running all the time. So I would continue progression after that. And also capturing cookies that come back in the feed. Those get sent back to the master node. I mean, everything was fully orchestrated here. So it was, navigation was happening, but again, it was not happening in Nightmare.js. At least it was very minimal. So what went right there? At the end of the day, like, again, this was a small percentage. If you remember my numbers, I was doing 7 million a day. This thing was doing 16 million a month, I think, after launch. So it wasn't meant to replace everything. It was meant to replace some really painful systems that were waking me up on a regular basis. So it did achieve that goal. Parsing with Floki in Elixir, and it's no I have no issue with Floki. Granted, I haven't used it in about a year, but I know there's a number of other parsers out there. I'm not particular. But it worked good enough for what I needed to do. Parsing was never my bottleneck, let's put it that way. The other big thing, though, was the niceties of being able to have that real-time UI. I could see all the jobs in my system right then. If something was running slow or there was a job that had to do some retries, I saw it right away. I had a lot of tools with the big spend on tools like Datadog with StatsD being emitted all over, even in my old systems, but just having that nice, quick interface to go glance at and see real-time what's going on in the system was really cool. In this system in particular, though, it wasn't perfect. Those RPC calls are terrible. I mean, terrible is not the right word, maybe, but they become tough to manage, and they were one of the sources of my worst crashes in the system because of some bad logging on my part. Anybody that's fought with the logger in the old days, it's better now, but you can fill that buffer up pretty quick and make your life painful. I was also, manually managing those nodes. I was sitting there looking at that CRDT going, oh, can I send this job to here or here? And that really wasn't the best use of time. And a malfunctioning crawl node, so I mean, it wasn't uncommon for a crawl node to go berserk. I started having zombie processes because for some reason, things aren't being trapped correctly in my URL port. And then that node would still get jobs that could not succeed. So because, again, I was pushing things based on some preconceived determination, I didn't really have a good way to provide any back pressure at this point. So then it was time to refactor. Right about summer of last year, I started working on an improvement on the system, started from scratch. A lot of the same principles, though. Almost everything's the same, but you'll notice I switched to Puppeteer for the headless crawling. Some things that were nice about that, it uses Chromium under the hood, and it was really easy just to run locally. So those really basic crawl scripts that I would use, I could easily just handle all of that on my laptop or have somebody else that was proficient in JavaScript handle that. For the most part, though, all the other tooling is the same, just a little bit simpler. And the big star of that is GenStage again, but this time I also want to mention that my crawler nodes, all of a sudden I took them out of on-premise data center and put them out on EC2. Now, the other curveball I threw in there is I realized right away again that those RPC calls and pushing that work to the crawlers was not ideal. So I was able to utilize GenStage, and I didn't even know how it was going to work. But after some quick tests, it worked way better than I ever imagined. So I was able to implement another queue inside my master node. Basically, that was the jobs that were ready to crawl. All of my crawler nodes would come online. They would basically subscribe to that producer over the web, and that's going from, I think I was running in Virginia, and my master node was in Dallas, Texas. So, I was thinking, are we going to have problems here? Am I going to get a lot of drops? It was actually way smoother than I thought. So if you've ever been afraid to try GenStage over the internet or across data centers, give it a shot because it actually worked out great for me. And the other thing is, again, I had that fundamental idea in my crawler, my master node, and those processes that if I sent a job out to a node and it didn't get done in a certain time period, I just considered it like, I'm going to just send it again. So I had a resiliency factor baked in there to where I could lose EC2 nodes. And Jason Goldberger sitting in front of me, he saw the system running last year at one point, and I was actually demonstrating where I could go into EC2 and drop nodes in real time, bring nodes up, it would automatically scale out and balance itself. So,
It's very intimidating.
Yeah. So on that system, an average month, we were able to kind of pick up those crawls, and actually it ran a lot lighter too. So 22 million crawl jobs was the average a month on that. Averaged about 50 errors a month, which really knocked that error rate way down. And I was running, I think at peak, I ran 20 crawl nodes. They were EC2 spot instances, and I'll actually talk about the financials there. I was running 17 Puppeteer procs per crawl node. I could have ran more. I was not actually using all of the machine instance that I had. But basically, those numbers work out to be like an average daily throughput of 725,000. Average hourly throughput I was hitting was around 30K. And I was able to, I wanted to see how hard I could push this system with these exact same counts, 20 crawler nodes, 17 Puppeteers. And I pushed it harder. And I was able to hit peaks of around 2.253 million per day. But I wasn't going to go that hot because there's a number of reasons why you may not want to be that aggressive. But the system was absolutely capable of handling pretty heavy loads and worked out really well. The costs here, to be totally transparent, I was bidding on I kind of found a sweet spot on an instance, looking at some historicals. It's an M4 X large on EC2. I was able to get that down to like 6.5 cents an hour. I don't remember what the original price is on those. They are network optimized. It's basically a 4 CPU, 16 gig machine. So I was not really touching all of that memory with those crawls, but that was a pretty solid price. Network bandwidth was running me, again, this was going across the country, which was not ideal, but it was running me about 18 bucks a day for this system. So, you could do the math there. It's, I got it listed too, but the daily spend, on the EC2s is 31 bucks, and hourly, $1.30. You could factor in that network connections. The other thing I want to be clear about there, I was doing no compression. Binary data is notoriously heavy in the beam. And so I could have definitely compressed that data on the crawl node to send back. I wasn't doing it because it was still so cheap. I'm like, why bother fighting decompression on the other side of the wire if it's working? So, what went right on that was GenStage across the wire was way smoother than I imagined. So, again, I'd encourage any of you that have thought about it but shied away, no matter the use case, I'd say give it a shot because it actually performed excellent. In the Puppeteer Chromium situation was more stable for me than Nightmare. Mileage may vary. But if you think about what was built here, it wasn't, if we take crawling out of this mix, you were to look at that, the end piece where the port was calling Nightmare or any sort of browser or an HTTP library. The thing I actually take away from this more than crawling is the fact that, at the end of the day, this kind of was a pretty scalable processing platform. That end result could have been anything. It could have been, FFmpeg or file encoding. It could have been image processing. So you could really think about just taking that node, that last crawl node, and replacing it with some other business logic, whether it's ETL pipeline or grabbing data for a client, from their API, et cetera. And the analogy that I think of, I don't know why, I'm from the Midwest originally and around a lot of construction equipment as a kid. I think about those excavating machines. You got the machine that does the one thing, but attach different attachments to it, right? And this platform, this paradigm, I've actually recycled a number of times since I built it to where, I put a new attachment on the head of it. So it is a pretty resilient pattern. Like I said, at the end of the day, it was cost effective and efficient. And that's all I have.